Kia ora koutou katoa, ko John Reid tōku ingoa. Welcome to this edition of Water New Zealand's podcast series, Tāwara Aotearoa. I'm John Reid from Water New Zealand. Today we're going to talk about an issue that's a really high priority across the whole world, that is non-revenue water and water losses. Aotearoa recently published its first network environmental performance report covering the year of 2022 and 2023. This brings together data provided from each of the 67 water suppliers from around Aotearoa, New Zealand. Some highlights about non-revenue water and leakage from the report. So a couple of things. About 900,000 customer residential meters in place in New Zealand, and about a third of urban areas are currently unmetered, and about half in rural and mixed population areas. And really, in the estimates of current annual real losses ranges from almost 400 litres per connection per day in rural networks to about 140 litres per connection per day in urban networks. But overall, really, leakage in New Zealand is really not that well understood. And the estimates that were provided to Te Aotearoa are unlikely to be accurate. So with me to discuss this topic are two special guests. We've got Emma Milburn from South East Water in Melbourne and Jeremy Heath from SES Water in the UK. So Emma's acting GM of Research, Innovation and Commercialisation at South East Water, with a focus on developing tech solutions that will enable, amongst other things, reduce leakage. Jeremy is Innovation Manager at SES Water, and he spent many years in the leakage reduction space. He's also the program lead for UK water industry researchers' big question: how will we achieve zero leakage in a sustainable way by 2050? And with me to co-host this podcast today is Dan Johnson. Dan is a member of Water New Zealand's Water Efficiency Group. He and I recently contributed to the update of the New Zealand Water Loss Guidelines, which were published last year. So hopefully we're in good hands today. Kia ora, Emma, Jeremy, and Dan.
Hi, thanks for having us.
Thanks, John.
Hi, lovely to be here as well.
Thanks for joining us today. So we thought we'd just start by touching on some terminology so we're all on the same page. Dan, maybe over to you.
Yeah, I think that's a good idea there, John. I think before we jump straight into the detail, it'd be useful for us to understand what do we mean when we're referring to non-revenue water or water loss. I guess in a technical context, water losses are defined as the discrepancy between the volume of water introduced into a distribution system and the volume that is ultimately billed to customers. So pretty simple, right? But I think there's a lot more to it. So I was going to ask Emma, can you tell us a little bit more about the components of water loss?
Yeah, absolutely. So, I think in most water utilities, there is the ultimate term of non-revenue water, and as you described there, Dan, that's the differential between the water in and the water out. Those there are two main components that make up that non-revenue water loss. One is apparent losses, so they're things like metering inaccuracies or unauthorized consumption. Here in Melbourne, if the fire services use water, that falls into that apparent losses category. And then there are the physical losses, so leakage in various forms across the utility network. And that's a fairly well understood, they're well understood parameters from the International Water Association.
Yeah, we have a slightly different situation in the UK. So we don't do non-revenue water. So effectively, when we started looking at leakage seriously, which is kind of back in the 80s or so, we had very low metering levels in the UK, and therefore we couldn't do that kind of, okay, what if you put in what comes out? So we had to come up with another way of doing it, and we did that by looking at what's called night lines. We looked at how much water is used at night when usage is low, and then making estimates and such like, and that allowed us to make an estimate of total leakage. So effectively everything that's leaking at 3 o'clock in the morning. Okay. So you can then say, okay, if it's leaking at 3 o'clock in the morning, we can make an allowance to say, well, it's going to be leaking during the day, and we can adjust that for pressure. The issue with that is it means that you pick up everything that's leaking, including customer side as well. So in the UK, we also have to record customer side leakage, there's a small allowance made for internal plumbing losses and things like that, which again is an estimate. But certainly things like supply pipe leakage, which in most countries is not counted as leakage at all, it's gone through the meter, it's being paid for. In the UK, we actually treat that as leakage as well. So our leakage figures always look higher than other countries because we're including that supply pipe leakage in our figure.
It's really interesting you say that, actually, Jeremy. We have about 100,000 digital meters in the network at the moment. And of those, 18.6% of customers have had a continuous flow notification, which is indicative of a leak of some sort. So the percentage of customers who actually have some kind of continuous flow or leak is far higher than we anticipated. So it's really interesting that you're covering that in your leakage figures, and likely the estimate is lower than you would expect.
Yeah, so we generally reckon that it's about a third. A third of our leakage is actually on the customer side, and what that does is that drives very different policies. We focus a lot on how we can assist customers in finding and fixing leaks and working on that side. And the danger comes as you only look at your mains network. What doesn't help is when you get international comparisons. People go, oh, look, the UK's got massive, great big leakage. You're going, actually, it's a third more because we're including that customer side as well.
And so in New Zealand, we've got the situation where, in some places they're fully metered, and in other towns and cities there's very little metering. So, the policies and the approaches that we take here are going to have to take account of that.
I guess moving on to another sort of approach is to understand how the UK particularly has approached, really going back to what you said at the start in the introduction, addressing moving towards a zero leakage. And if you look back at where the UK's journey of where they've come since, I think it's 1997, where leakage has been reduced by about 40%, and as you say, it's quoted about 20% now. There's that commitment that the government has sort of imposed on water companies to do better, to reduce leakage further, and the policy was to try to achieve I think it was a 16% reduction between 2020 and 25. So Jeremy, can you tell us what are the UK water companies doing to address this target, and what is PALM?
Fine, yeah, let's talk about that. I think firstly, let me set the challenge as well. Is in the UK, there was an independent audit carried out by what's called the National Infrastructure Commission, and they looked at the UK as a whole and said, okay, what's the shortfall in water by 2050? And the figure that they've come up with, they published 4,000. Oh, there you go, giving that away straight away. But in fact, they said that's bigger than that. It's 4,800 megalitres, so million litres per day by 2050. Now, that's the difference between how much water we'll need and how much we've got. Okay, it's the equivalent of three of our biggest water companies, their entire distribution input for a day. So we've got to find a load of water or save a load of water. And they said there's three ways of doing that. Reservoirs, we're going to build reservoirs. Number two is we've got to reduce our own consumption. So that's things like metering that Emma's been talking about and things like that. But then the other way is we've got to halve leakage. So though you're seeing a reduction at the moment, all the water companies in the UK have committed to halving leakage, and we're all working on doing that. So there's a massive drive towards doing that at the moment. So how we're doing that? So traditionally, leakage managers, and when you look at leakage, it always tends to focus on two areas, which is finding leaks, okay, and locating them. So finding is typically where are they breaking out? That's kind of the geographical area, and then it's sending people into that area to go and look for the leaks, which you then carry out and do repairs on. And when we looked at this, we realised that what was happening is most of the focus was going in that area. And we said, no, it's got to be broader than that. If you want to manage leakage, you've got to think quite wide. And so we came up with this acronym PALM, which stands for Prevent, Aware, Locate and Mend. And we said, okay, if you're going to manage leakage really, really well, you've got to do all four of those brilliantly. Okay, there's no point in just concentrating on one area and throwing your money at that. Yeah, you won't solve leakage. And so we have a lot of work going on in prevention. That's about mains repair. That's about pressure management, so dropping the strain and pressure on your mains. Transients as well comes into that. There's pressure waves that go through our pipes as valves open and close. Try and reduce those down. So make your network calm and make it robust. awareness. Where's your leakage breaking out? Is it on your mains? Is it on your supply pipes? And then which geographical areas? So dividing your network up and going and saying, okay, we're going to measure the areas and know what's going on in those areas and what's happening with the leakage. So that's your awareness side. Location, literally sending people out into the ground or using acoustic logger systems. Where are we going to go and dig, to actually carry out the repair? So that's the location side. And then finally, mend as well. And the danger comes is that you pour millions of pounds into those other areas, and then actually you then take 6 weeks carrying out a repair. So what we've got to do is drive down the repair times as well.
I guess the next crucial point is how to invest and how far do you go. So obviously it's crucial to acknowledge that really a completely leak-free distribution network is an ideal, but may not be a sort of achievable in the terms of how do you approach that, and in terms of understanding how much to invest, and then what is that in terms of the point of no return in addressing leakage.
Yeah, I always call it it's the 100 penny problem. You know, if you dropped 100 pennies in a field, how long do you spend picking them up? Okay, you're going to find that first 70 pence, 70 cents really quickly. You're going to gather those up, and then there's still 30 cents or 30 pence out there, and you're thinking, okay, where do I go for that? Okay, you bit more searching, find another 10, and there's still 20 pence out there, 20 cents. You're going to go, it's not worth my time. It's not worth my time looking for those. So in fact, I'll just leave that, because the cost of finding that and locating it is not worth the value of what's there. Every company has to do that. That's called the sustainable economic level of leakage. It's how we work it out. We say, what's the cost of finding this leakage against the value of the water that we're losing? So that's been, in the UK, the predominant factor for about the last 10 years. Most companies were at or near their sustainable economic level of leakage. And so if you look at the graph, it goes, oh, they're not doing much in terms of reducing leakage. No, most companies were at that level, and therefore our regulator was saying, I don't want you spending loads of customers' money to drive it down even further. That's gone out the window. Climate change has ripped up the rule book and basically said, look, that shortfall that we're seeing in our water availability and demand is so large that we've got to drive down leakage to unprecedented levels. And the economics have completely changed. And we've now moved from SEL, sustainable economic level of leakage, into what I call SAL, the socially acceptable level of leakage, okay, which is way lower, is what our customers are going, this is where we think your leakage should be. And that is as low as you can possibly get it. So it's really changed in the UK. Emma, how's that been for you?
Yeah, here in Australia, we have sustained fairly significant droughts over the not too distant past, and we're in a scenario at the moment where our dams are particularly full. We've had heavy rainfall over recent years, but we're also, as a sector, really conscious that we can't rest on that, and we know that very quickly the impacts of climate change will affect us. We've got in Melbourne, huge population growth. Our population is projected to double by 2070. So the idea that we can sustain that level of growth with those climate impacts in the long term just isn't feasible. We do have a desalination plant in Victoria, and there are potential plans for another. But the more that we can defer or delay that augmentation, the better that is for our customers, for the environment. So whatever we're really focused on, what can we do in order to save water, to defer that investment in the augmentation. For us, that means working with the other utilities, the other retailers in Melbourne, and looking at that long-run marginal cost of water to see actually, what sort of investment is economical. And for us, that meant looking at our digital metering rollout. So this is a fantastic opportunity where we are going to deploy over 1 million digital meters into our network over the next, during this pricing period, so over the next sort of 4 or 5 years. And South East Water really, thoughtfully stood back at the start of that process and said, well, if we're going to roll out a million devices, what else can we put in them? And so that's where this idea of a sensor that looks back into the network while the digital meter is looking at the customer side leaks, that came about. And that really helped us to get a positive business case for digital metering. So we're looking at, quite large savings from customer side leaks directly to the customers, those savings are, and then network side leaks, which obviously reduce our non-revenue water. So our hypothesis going into that and what we've modeled for our essential services pricing submission was to reduce our bulk supply, the water that we bulk supply from Melbourne Water, by 1%. And that really helped us stack up that business case over a 25-year period.
So we've talked a bit about how in the UK we've got this economic levels of leakage. We've got now a lower level, which is the socially acceptable level of leakage, coined by Jeremy. But what does good actually look like? In what we're seeing in New Zealand is really some quite high levels of leakage, and probably and apart from one or two suppliers, probably we don't really know accurately what it is. But maybe kick off with Jeremy. What do you think good looks like in a metered supply, for example?
In terms of where we are at the moment, in the UK, and it's interesting, thank you for quoting your figures earlier. So in the UK, we're looking at litres per property per day around 130 as an average. But that's skewed by a couple of the large companies who are frankly struggling at the moment. And so therefore, if I quote my own company, we're running at 76 litres per property per day, roughly. Okay, in fact, it's lower than that now. But remember from what I said earlier, is probably a third of that is on the customer side. So actually, we're probably running somewhere around 50 litres per property per day. Okay, that's good. I'm going to say I'm not happy with that. Our job is to drive it down considerably lower than that, as we've already discussed. And when you look nationally and when you look internationally, that's a good figure, but it's nowhere near in terms of some of our other European countries, particularly if you look at somewhere like the Dutch or the Germans, who have considerably lower leakage than us. They've done that by massive mains replacement programs. We haven't got that option.
Look, I think that context piece is really critical, and I don't know that we should be trying to get to a global figure of what is acceptable or what is good, because, as Jeremy said, age of the assets, the desire for utilities, but governments to invest in new infrastructure versus try and maintain or repair existing infrastructure, that, just factors around the water and the makeup of that water really impact that supply. So I think that looking at making sure that we're making improvements, that we are deploying the right technologies, but under the right circumstances and with the right teams and processes behind those technologies to support customers to reduce their leakage on their side. It's all very well to give customers that information, but how are we then supporting them to use that information, I think, is really critical. And then also doing everything that we can on our own network side in detecting those leaks, but also in fixing them in an economical fashion, so that, as Jeremy said, we're not chasing those very small leaks that actually are more disruptive to fix than to leave.
Yeah, I think that's important, isn't it? There's no right answer.
Yeah, I think there's another thing we need to consider really is technology and the role technology plays in the water industry. Obviously, there's so much happening in terms of leak detection, pressure control, data analytics. There's just a breadth of so much thing happening and evolving. So I guess it would be interesting to know how is the UK so embracing that technology and staying abreast of what's coming out and how it's being used in the industry.
Yeah, so there's actually been some real changes in technology coming through in about the last 5-10 years. So my role is, although I do a lot with leakage, I'm an innovation manager. So in fact, my job is to scan the horizon for the latest stuff and to see how we bring that in. A few years back, I was looking at two technologies that were coming through. One is called the Internet of Things. It's the ability to send small packets of data on a really frequent frequent basis. Is what Emma's metering solution, her smart metering solution, will be based around. There's a lot of this now being rolled out across the world, but we were really early adopters of that in the UK, and we're looking at this technology and going, this could be a real game changer in terms of the amount of data that we could get back. One of the problems that we've always had is that we have loads and loads of data from our treatment works about what's going on. Yeah, they're all hardwired in. You get data in milliseconds, you know, something happening there, pumps going on and off. Okay. At the other end of your system, you've got your customers. I have one every 12 meters, okay, on average. The latency of them not having water and picking up the phone is measured in minutes, okay? In between, you have your network that sends the water around. The trouble is the amount of sensors we have on there is probably one every 1,000 properties or so. And also, the latency of getting that data back is generally measured in hours. And that's why when customers are going, why doesn't the water company know what's going on? It's because they know what's happening. Yeah, but if it's on our network, yeah, we've got that latency. When we were looking at this, we looked at the Internet of Things and we said, look, that can allow us to get in a situation where we know before our customers do. So what we did is we rolled that out across my own company. We rolled out this IoT network all the way across my company, and we changed it. Instead of getting data every hour, we now get it every 15 minutes, and we actually sample it every 1 minute all the way across the network. The trouble is fantastic. You've got all this amazing data. How on earth are you going to manage that? Because we couldn't manage previously with the amount of data we got. The only time we could really look for leaks was at 3 o'clock in the morning when the network was quiet. And that's as much data as we could cope with. So the second technology I was tracking was artificial intelligence. Now, artificial intelligence is really good at looking for patterns and going, something has changed. And so what we did is we taught it and we said, this is what normal looks like within our areas. And we actually individually taught it for every single area. And it says, for 1,000 properties, this is what normal looks like for that area, based upon this 1 minute data that it's receiving every 15 minutes. When we rolled that out and when we started trialing this, what it demonstrated is, in fact, we can find leaks very, very quickly using that method. So typically we'll find hidden leaks. So that's a leak out in the road outside my house, nothing showing on the surface. We'll find that within 2 hours within the area. Now that's good. But then we went a step beyond that and we said, okay, how else can we drive down our location times? Because that helps my awareness time. We've now started rolling out some additional sensors as well within our network that look for small localized drops in pressure. Using that technology, and in one of our trial areas recently, we actually found a hidden leak in 45 minutes and it told us which street it was in. So what we're using now is we've seen these combinations of great sensor technology coming through, tied in with great analysis that can say, this is what's going on within your area. And that's been game changing for the industry. And in fact, what's really interesting is exactly what Emma is probably going to leap in and talk about now, is bringing in the customer side as well, which is another data point. It'll just tell us something else that's going on there and providing that additional information as well.
Yeah, absolutely. Look, we've at Southeast Water taken a really similar approach. As I mentioned earlier, we really took the opportunity around that digital metering rollout to pack those meters with sensors. So we're about to finalize the tender for those 1 million digital meters, and 60% of those will include the SOTO vibration sensor. So essentially, we're deploying those on a one-to-one basis within the digital meters for reasonable sites, so not high-rise buildings, not new developments, but apart from that, on a one-to-one basis. And about 5% of the network will have pressure sensors included as well. And what that helps us to do is to triangulate and locate to, within a few meters really, where a leak or where a suspected leak or a vibration is, and then get the crews on site and really, focus their attention on where we suspect the leak is. On the customer side, customers are now not only being given the information that they need to be able to save water and also what they expect, because they're getting lots of information from sensors from other utilities, from their telco provider. They're getting a lot of information that then helps to understand what their water use looks like. And that does two things. One, it helps detect if there's a leak, and we are running a continuous flow program at South East Water, which is now BAU, which is notifying customers of continuous flow on their property. Depending on the size of the leak, we're sending that first notification either day 1 or day 7. And that not only tells the customers that they potentially have a leak because we've detected continuous flow, we're also estimating in a monetary sense what that would look like if they don't fix that before their next bill is due. We bill quarterly here. So that's been a fantastic program, and to date we've saved customers 5.7 million Australian dollars.
I guess with all this technology, where do you see it heading? I mean, where's the limit? I mean, Emma, what do you think? Where will we be in 5 years, 10 years?
Yeah, look, I think that it's not only the advances in technology and, you know, that like Jeremy talked about, the telecommunications technology, the sensing technology, but also the cost of that technology is coming down rapidly. And that means that utilities can deploy these things at scale. You know, 4 or 5 years ago, maybe we could deploy small scale trials, but actually to scale across a utility network was cost prohibitive. Look, I think that AI is probably well understood to be very beneficial for not only the water utilities, but more broadly. But I think it's just about thinking through how we use that ethically and how we are ensuring that, you know, we're using AI for the right things and not as a blanket approach to everything that a utility does.
Yeah, I think the other bit as well, looking at it, is there are very good solutions coming through now about awareness and location, exactly as you heard. And I think a lot of that will simply be rollout of those. Okay. If you look at the prevent side, that's about your mains laying techniques, that's about your pressure calming and things like that. There will be advances in those areas, typically in terms of things like spray lining, semi-structural lining, better ways of doing that. But I don't think there's going to be game-changing technologies coming through in that area. It'll still be the case that you've got to isolate a pipe and clean it out and then line it or replace it in some way and things like that. And that will just be a steady progress that we go through the years of changing our pipes. Where I think we will see the next breakthrough technologies are probably going to be in mend, probably going to be in the repair side. What will drive that is companies, they will get their awareness, they get their location times right down really quickly, by employing these techniques across their networks. And you can do that within years. And then suddenly you're going to be up against this problem of going, okay, fantastic, we can now find these leaks within 2-3 days, locate them very, very quickly. It's still taking us considerable time to carry out the repair. And the reason for that is typically we carry out the repairs the same way the Romans did. Dig a big hole, cut out the bad bit, piece through. That's what we've got to change. And so therefore, where I see the real changes coming through are going to be in repair technologies. A lot of the work I'm doing at the moment is working with universities on robots. And it sounds so high tech. We go, yeah, robots in pipes. But you know what? I think within 5 to 10 years, we will see that as a solution, that literally where we have a burst is that we will have robots going down the pipes, locating that, and then sealing it from the inside. Just before Christmas, as you heard earlier, I have a national role. I'm UCWIR, which is UK Water Industry Research. So I did a road trip. I met with every single water company in the UK, sat down, did a deep dive with them about all the research that's going on at the moment, understanding what their problems and issues are. And what I also managed to do was persuade them all to share their research plans. We actually published that. It's on the UCWIR website. It's something called the Leakage Innovation Heat Map. And it allows us to actually go, okay, where's all the research occurring? Where's the gaps? How do we manage our research? How do we collaborate? One of the things that came out really interestingly was how much research is going into those 4 areas of palm. What it found was that 70% of the research, almost split equally, was on awareness and location. That's because that's where your leakage managers have direct control. They can bring in technologies and solutions. About 20% of the research was going on prevent, okay, mains laying solutions, pressure management and things like that. Only about 10 to 13% is actually going on repair. is on the MEND side. It's the lowest side of our kind of research area. And that's why I've been, having a bit of a kick in terms of, right, this is where we need to start putting more resources in. Our regulator has just done a big exercise with us about the next 5-year programs. And as part of that, they have a huge data gathering exercise, which is then published across the UK. So every water company published, this is how we're going to spend money. And as part of that, they said, this is how we're going to spend it on leakage. Ofwat very nicely said, let's break it down by palm. So Ofwat said, give me all your costs on leakage broken down into prevent, aware, locate and mend. And what that told us for the first time is that 52% of leakage spend is repairing the pipe. So only about 11 to 13% of our research is on repairing, 52% of spend is on there. Okay, so that's the dichotomy, and that's why I think mend is going to be one of the big areas that we're going to have to address.
It's fascinating, isn't it? And go back to what we said at the start with the first Aotearoa Network Environmental Performance Report. The data quality is pretty poor. You can see that hopefully in a decade or two, we'll be in the position where we still have a similar amount of data, so we can really understand what's going on in all the spaces related to water supply and wastewater. Really want to ask you both this question, which is really, hopefully we can keep it one key lesson that you've learned over your time around leakage, and maybe almost a bit of advice for us in little old New Zealand. What is sort of the key lesson, Emma, that you've learned over your time that sort of stood out to you in this space?
I think a key lesson for me, and it's probably come, from a digital transformation lens, is that Southeast Water had some great foresight in planning out all of the processes that would be impacted by digital, all of the processes that would be impacted by digital metering, the teams and the skills and the capability that would be required to really embed the technology well, and not only at trial scale, but enable that to scale across the utility. And without that, there's a real risk of things being successful at trial scale, but then unable to scale out across the utility. And so the real benefit is never realized.
One of the bits, as I've said, that we found in the UK is collaboration is driving us forward. So in fact, I'm off down to the southwest of England, and after this meeting, that's a collaboration meeting. We're getting all the water companies together just to look at supply pipe leakage and look at solutions that we can share. And I think if I was going to say anything in terms of encouraging you, is learn from one another.
And yeah, look, I think in New Zealand, there's that extra challenge of there was an anticipation of consolidation, which would have given some scale, but that hasn't played out exactly as people maybe expected. And so then how do smaller utilities or councils that are managing far more than water and wastewater get not only the resources, but also the internal capability and capacity to be able to take on these digital projects? I think that's a real challenge.
Yeah, I think that will come down, like we said, to collaboration and for us working together with the likes of the Australian and the UK water companies. So I think that's a great place to finish. Thank you very much for your collaboration, Emma and Jeremy, and for joining Dan and myself today. It's great, really great to talk to you about non-revenue water and leakage and some of the things that we can all do to try and improve. Thank you for listening to this latest episode. We'll be back next month with our next podcast.